Hi, welcome my dear students. Let us solve the second problem. Okay, this is the continuation of the previous part. Okay, that is friction problems part 3. So this is problem parts 4. So determine the force P that must be applied to the 20 kilonewton block B to lift 100 kilonewton block as shown in figure. So the coefficient of friction is 0.3 for all the surfaces. So this is your block of 100 kilonewton. Okay, this should be lifted by this 20 kilonewton block. Okay, so that what is the force needed? Determine the force needed that should be applied so that this block, okay, this block should carry this 100 kilonewton weight block. So let this be A and this be B. Okay, now as same procedure is same. Okay, consider the, now I'll follow the solution. So what is the given? That is coefficient of friction is 0.3. What it means? Any F1 value if we are taking means it will be 0.3 R1. Okay, 0.3 R1 like that. Okay, so this is given for that purpose only. So I'll take the consider okay, FBD, free body diagram of block A. So this is the block A. So consider only you draw the block A. Yes, this is the block A now. Okay, let this be the imaginary horizontal surface. Okay, now this is 20 degree. So here this is 20 degree. So the same angle will be there at 20 degree. So it is slope. Okay, now what we do, we will calculate where are the surface contact surfaces so that we will get the R1, F1, R2, F2 like that. So whenever this block pushes, okay, so that 100 kilonewton should be lifted. So whenever there is lifting, so here is the wall, contact surface is there, it will not go across this, it will move up and lift towards the right. Okay, it will simultaneously it will be move up and it will lift towards the right. So the motion trend will be like this. For this, the motion trend will be like this. This is the motion trend. So opposite to the motion trend will be your frictional force direction. Okay, now I'll take here that this may be R1 and opposite to the motion force this is maybe the 0.3 R1. Okay, instead of writing F1 I am writing directly 0.3 R1. Now there is also contact surface here, you can see. So from that contact surface also one reaction will be present, will generate. So this is R2. So empty is this side, so your F will be like this. So this is 0.3 R2. Now this is how much is the weight given? 100 kilonewton. Okay, now we will calculate by the equilibrium of force concept. I'll take first, as we took in the last class, summation of V is equal to 0 taking upward as positive. Okay, so see here you have here two inclination of forces, two inclined forces you have, right? So we have to resolve that. So one will come like this and another will come like this. So this is for 0.3 R2. So theta is like this, no? So they will get this as theta. This is 20 degree. I'll take the red pen. So in the red, I'll mark so that it shouldn't become confused. So see the force is here. This is 0.3 R2 force. Okay, so this force I'll just resolve into one vertical and one horizontal. So this direction head is like this, so the head will become like this. So what is this? 0.3 R2, 0.3 R2. So this is 20 degree, correct? So it will be 20 degree. So here also 20 degree because of zigzag angle or alternate angles. 20 degree. So with the angle it will be a member of cos. So without the angle it will be sine theta. Sine 20 degree, right? Cos 20 degree, sine 20 degree. Then another force inclination is this R2. So when I take vertical, right? When I take vertical forces, then the angle here will be 20 degree. Okay, so this force can be resolved by, so see here, this one force, another vertical forces will be like this. I am purposefully I'm making it long so that you shouldn't confuse it. Okay, so we know that this is 20 degree, so this will be 20 degree. Okay, zigzag angles. Okay, if you take also from this side also you can take how, this one and this one, so the value will be same. So this will be your R2, this will be your R2. So angle is here, this will be sine 20 degree, this R2 cos 20 degree. So fine, now we'll take only one force. Okay, summation of V, summation of V is equal to 0, positive. Okay, don't leave any forces now. Summation of vertical forces is equal to 0, taking upward as positive. So which are the vertical force? First you note down that. Okay, so 100 kilonewton, so minus 100. Then this 0.3 R1, that is also minus because direction is downward. Then you come to this inclined force, any one you take. Let's take this R2. Okay, when this R2, I want the vertical member, so vertical member is R2, that is upward, right? R2 cos 20 degree. So after that vertical member you go to another force, this is F2, that is 0.3 R2. I want vertical member, it is 0.3, that is negative 0.3 R2 sine 20 degree is equal to 0. Okay, now so minus 100 minus 0.3 R1 plus our cos 20 will be 0.939 R2 minus sine 20 into 0.3, it is be 0.102 R2 is equal to 0. Therefore you will get the value is 0.3 R1 plus 0.84, when I subtract R2 is equal to 100. So let this be equation number 1. Fine, now I'll resolve the forces in horizontal direction, taking left to right as positive, all the horizontal forces. So take now one. So R1 is independent, take all the independent forces so that it will be easy. R1 is the horizontal force, then nothing, then I'll take our inclination force, that is R2 horizontal phase, this is right side, okay, left to right. So minus r2 sine 20 degree, then f component, that is 0.3 r2, that is also minus 0.3 r2 cos 20 degree is equal to 0. Now so r1 minus your sine 20 will be 0.342 r2 minus your cos 20 into 0.3 will be 0.281, r2 is equal to 0. Therefore your r1 is equal to this, both I'll send to that side, so it will become 0.62 r2, 0.34 plus 0.281. This may be equation number 2. Okay, now what I do is substitute equation 2 in equation number 1. So this, so 0.3 r1 is what, 0.62 r1 plus 0.84 r2 is equal to 100. So it will be, so 0.62 into 0.3, 0.186 r1 plus 0.84, so this is r2, right? r2 is equal to 100. Therefore your r2 will be 152.9 kilonewton. Okay, so it is 152 kilonewton. So I got r2. Now I got r2. Next step is I'll take the free body diagram of this section now. So take free body diagram of block B. Okay, so what will be, so block B is in trapezoidal section, same as we did in the old problem, no? Same. So this is the block B. So this is your 20 degree. So here one force is there, that is P. Okay, see, right? Then weight of this is, how much they have given, 20 kilonewton they have given. So your weight will be, I'm taking at the center because I'll tell you, here contact surface is there, here contact surface is there, because we here will encounter with the r2, here we'll encounter with the r3. Okay, so that I'm taking this center, so that we would not confuse in it later. So that's how its motion will be. Now after drawing, you just calculate the motion. So P force is in this direction, so it is going in this direction, so motion trend will be like this. So this motion trend will be like this. So motion trend, okay, if the motion trend is like this, the frictional force will be like this. Okay, so with this, another force, that is r2, when I take vertical, angle will be 20 degree. Then here also another force r3, opposite to that 0.3 r3, here 0.3 r2, same. Then we have to resolve this in horizontal and vertical direction. So whenever I resolve this, see here, so one horizontal force, one vertical force. Okay, so this is 20 degree. So what will be 0.3 R2 cos 20 degree. So 0.3 R2 sin 20 degree. Correct. 0.3 R2 sin 20 degree. 0.3 R2 cos 20 degree. Now, so F force was resolved. Now we have to resolve this R2 force. So R2 force, so this is force, right? So this force I will make so in this way, and I will make in this way, so don't confuse here. So this is 20 degree, this will be a 20 degree. So this force will be R2 cos 20 degree, and this will be R2 sin 20 degree. Correct. Then same procedure, summation of vertical forces equal to 0, taking upward as positive. Take one force now. So R3 is direct, R3, then minus this 20 I can take, then one inclination force you take, that is R2 cos 20, R2 cos 20, another this F vertical force is R, that is positive, 0.3 R2 sin 20 degree is equal to 0. Now you should simplify. Okay, so this R3 we don't know, minus 20 minus this R2 we know, that is 152.9, 152.9, then cos 20 degree, that is 143.67, plus here also, so 0.3, so 152.9 into 0.3 into sin 20, so that is 15.68 is equal to 0. Your R3 will be equal to, so 143.67 plus 20 minus 15.68, that is 147.99. so it will take as 148 kilo Newton. This is your R3 value. Now I'll horizontal force equal to 0, taking left to right as positive. So what are the horizontal force? First I'll take this minus point R3, then this one, that is positive 0.3 R2 cos 20 degree, then this R2 plus R2 sin 20 degree is equal to 0. No, I left this force, that is minus P. Okay, minus P is equal to 0. Correct. 0.3 R3, then 0.3 R2 cos, correct, then R2 sin 20, then minus P. Yes, correct. 4 forces are there. Now solve it. So we have R3 now, that is I'll take directly, so minus 0.3 into R3 is 148 minus 44.4 plus 0.3 into R2 we know 152.9, then cos 20, it will be 43.10, then R2 we know 152.9 to sin 20, 52.29 minus P is equal to 0. Therefore P is equal to 43.10 plus 52.29. Okay, it will be around, so it will be 139.9. 139.79. okay, so here you take 149.79, 139.79. now you can ask why I read 0.3, because it is a mistake here. You should, I forgot here. So this is like this, friction will be always opposite to this, no, so this is positive. Sorry, it was my mistake. Okay, so 0.3 R3, so it will come in only horizontal, so everything is right. So when I calculated this, I was getting less value. Okay, so I thought to recheck, so it is positive, so it is 139.79 kilo Newton p value. So like this way a wedge problem is solved, and it was a problem which was asked in the VTU in 2000 year, for the second sem. So next we will go to the, so wedge problem are like this only. Okay, 2 is enough for you. Now we'll go to the friction ladder type of problems. Okay, I'll explain you the problems on ladder, how to do. I'll just give an introduction, so we'll solve the problems in the next class. Okay, so what is a ladder? A ladder is a device used for climbing up or down. Okay, so a ladder is a device used for climbing up or down. It has two contact points. Okay, this ladder has two contact points. One contact point is with the floor, see here. Another contact point is with the wall, which gives reactions. If the contact surface is there, then we have reactions, right? If the floor and wall are rough, if the floor and wall are rough, then friction will come into play. Okay, friction will come into play, so that the friction force will also act here. So the forces which keep the ladder in equilibrium, that's shown in figure. So I will write the notations and where the friction will act. Okay, I'll write everything here. So this type figure will be there in your problems on the ladder. Okay, so the basic figure you must remember it. Okay, now see here, so this is the ladder, right? Okay, so this is the length of the ladder. So if this is the weight of the ladder, it is concentrated here, means, so at the weight only the distance between the ladder will be L by 2. At exact half, the centroid will be there, and there the weight of the ladder will act. Then here you see, let this be a point A and this be the point B. Okay, and due to the contact surface here, one reaction is produced or generated, that will be RA. Similarly, contact surfaces here, one reaction will be produced, that will be RB. So where the contact surface will be there will be one reaction, normal reaction to the surface. Now next, what is there? When we climb on the ladder, right? So when we climb on the ladder, 1 step, 2 step, 3 step, what will be the force? The force will be like this. Our force will make the ladder to move in this direction, and to this point will move this direction. You know, ನಾವು ಲ್ಯಾಡರ್ ಮೇಲೆ ಹತ್ತಿದಾಗ ಏನಾಗುತ್ತೆ, ಸ್ಟಿಫ್ನೆಸ್ ಬರುತ್ತೆ ಲ್ಯಾಡ್ರಲ್ಲಿ. ಮೀನ್ಸ್ ಸ್ಟಿಫ್ನೆಸ್ ಅಂದ್ರೆ ಏನು, ಈ ಪಾಯಿಂಟು ಈ ಕಡೆ ಹೋಗೋಕ್ಕೆ, ಮೀನ್ಸ್ ಈ ವಾಲ್ ಒಳಗಂಡ್ರೆ ಹೋಗೋಕ್ಕಾಗಲ್ಲ, ಸೊ ಈ ಕಡೆ ಹೋಗ್ತಾ ಇರುತ್ತೆ ವಾಲ್ ಹತ್ತಿದ ಮೇಲೆ. ಸೊ ದಿಸ್ ಪಾಯಿಂಟ್ ವಿಲ್ ಟ್ರೈ ಟು ಗೋ ದಿಸ್ ಸೈಡ್. ವೆನ್ ವಿ ಕ್ಲೈಮ್ ದ ವಾಲ್, this portion of the wall will go try to move in this way, and this point will come, it will try to come downwards, so that it is stiffened. Okay, so ಏನಾಗುತ್ತೆ ಅಂದರೆ ಇದ್ರ ಮೇಲೆ ಹತ್ತಿದಾಗ ಈ ಕ್ಲೈಮ್ ಮೇಲೆ, ಮೀನ್ಸ್ ಈ ಏಣಿ ಮೇಲೆ ಹತ್ತಿದಾಗ ಏನಾಗುತ್ತೆ, ಈ ಒಂದು ಸ್ಟೆಪ್ ಇಟ್ಟು ಅಂತ ಹೇಳಿದ್ರೆ ಹತ್ತಿದಾಗ ಇಲ್ಲಿ ಈ ಪಾಯಿಂಟ್ ಹಿಂದೆ ಬರ್ಲಿಕ್ಕೆ ಟ್ರೈ ಮಾಡುತ್ತೆ, ಆಮೇಲೆ ಈ ಪಾಯಿಂಟು ಕೆಳಗಡೆ ಬರ್ಲಿಕ್ಕೆ ಟ್ರೈ ಮಾಡುತ್ತೆ. ಸೊ the motion trend is So because of our force, when we climb, this point will come towards the left. Okay, the motion trend will be like this. This is the motion trend. So here the motion trend will be like this. It will try to come in down direction so that it gets stiffer and it will be in equilibrium, right? So this is the motion trend. ಸೊ ನಾವು ಹತ್ತದಾಗ ಇದು ಈ ಕಡೆ ಪಾಯಿಂಟ್ ಬಂದು ಮೋಷನ್ ಟ್ರೆಂಡ್ ಹಿಂಗಿರುತ್ತೆ, ಇದು ಕೆಳಗಡೆ ಬರುತ್ತೆ. ಸೊ when the motion trend is in this direction, here in this downward direction, how will be friction? Friction will be opposite to that. So here only at this point the friction will act as in this direction, here in upward direction. So this is friction. This is FA and this is FB. Okay, when the coefficient of friction of wall and floor, if they are different, then different. If they are same, this FA will be mu into RA, this FB will be mu into RB. If they are same, no problem. If they are different, what will happen? This is mu F, that is coefficient of friction of floor. This is mu W, that is coefficient of friction of wall. So these are the notations coming in the problem related to ladder, which we have to remember. So ಈ ಥರ ಫ್ರೀ ಬಾಡಿ ಡಯಾಗ್ರಾಮ್ ಮಾಡ್ಕೊಂಡು ಈ ಥರ ಎಲ್ಲ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದಾದ್ಮೇಲೆ ಏನು ಮಾಡಬೇಕು? ವಿ ಶುಡ್ ಅಪ್ಲೈ the conditions of equilibrium after making the diagram like this. Okay, after indicating or generating the reactions where and in which point they will be generated, after indicating that, we have to apply the conditions of equilibrium. Yavudu conditions? Summation of V is equal to 0, summation of horizontal force is equal to 0, and here another one third condition will come into play, that is summation of moment equal to 0. Okay, where the moment applies? So here force is there and here is the length, therefore the moment will apply at A. So in brief I have to tell you is moment about A will be 0. So what are the three conditions we need to apply? That is summation of vertical force is equal to 0, taking upward as positive in the problems. Okay, summation of all the horizontal force is equal to 0, taking left to right as positive, and summation moment about A should be 0. If we apply these three conditions, we will get the required force, or whatever they ask in this condition, we will get the answer if we assume the forces like this. So contact forces is RA, RB, so perpendicular them friction forces, so motion trend. So what you have to understand, when you step on the ladder, it will jerk towards the left side or you are behind, and the front point on the top point will come reduce to its lowest rough point, so as to withstand firmly. So okay, this was about the basics of the problems in ladder. In the next class we will see how the problems will be. We will take 2 examples on the ladder and we'll finish the chapter of friction. Thank you.